Greetings from my office in Billund, Denmark. But yeah, I'm a designer for LEGO Education. In the last years, I've been working closely with First LEGO League and helping design the challenges and going to events and competitions and things like that. So helping it make it better for you guys. And I've been teaching LEGO robotics. I've been a FLL coach before, and ready to answer questions for you guys. So, welcome. I think open the box and get in there, get started. But for me, I always like to ask kids if they know what robots are. And most kids know what robots are in some shape or form. Where have they seen robots? Where have they seen things like that? Defining a robot is always important, even at a young age. And once you get there, then you ask them about Lego, and if they know how to play with Lego and know how to put stuff together, and how about making a Lego robot. And I think it's a great start to getting to getting your EV3 into your young kids. Maybe if you have an old one already, practice on that. See if you can do certain missions. But sometimes it's a good idea to work on types of driving bases. And I like to try different types of robots, starting to build stable, and not having to worry. It's a good time to not have to worry about the project just yet and get a head start, even without the box. I do a little bit of YouTubing and searching for how other people have built robots for FLL. And if you're just new and you don't have anything, I would probably go with doing a little bit of research on what FIRST is, and then what people have done before. Every year is different, so don't take those too seriously until the challenge comes out. But just see how people have actually done things in a different way. And you should also try and get an idea of what you can do and what your limitations are. So it's a good pre-season things. And if it's a post-season, sometimes I do like robot fun stuff, like building sumo bots. Line following techniques is really good. Everything from the most simple, basic line follower, like if you guys can see my screen, the real basic bouncing line follower with just the color sensor and two motor blocks, two move blocks, for example. So the more advanced one, learning how to stop, stuff like that. And for the more advanced teams, I try with variables and trying to make a program where you can put all of your smaller programs into, like all of your missions into a single program, just to learn how to save time. Things like that. Those are pretty good to know for pre-season starting. And what else? What else is good? Learning how to turn, seeing what your robot does on curving and things like that. Learning how to play with the gyro sensor is really good. I've seen some great teams in the last competitions doing awesome stuff with the gyro sensor. So brush up on those things. Play with your sensors. Again, if you have a good robot to start with, then you can already figure out how to get from point A to point B. And, good ones. So the one I have on screen is a simple line follower, and they can get much more complicated than that. Learning how to stop. Again, learn how to do some of the basics, moving forward and getting comfortable, changing the parameters around of your move blocks. So I think getting really comfortable with these dials and knowing what happens when you have your steering movement, things like that. Those are really, really important to do, because once you have your robot, this is going to be the block you're going to use most of the time. And even understanding what happens when you have it on and you're looking for a black line or something, see what happens to your robot. Knowing what it means to find a black line and stopping at it. I think those are the really great basics to get into. And again, once you get there, you'll have a lot better learning how to move around and navigate in the field. So navigation is super important, and knowing where to start your robot. Definitely the color sensor and the light sensor and the different modes it's in. So the color sensor has two different modes. You can look for colors, red, black, blue, green, yellow, brown, and white, and no color. And a lot of people forget about reflected light intensity. So this is when the color sensor uses a single light color to reflect the light on the field. And it's not just a color sensor, it's also a light sensor. So I definitely get started using this. And there isn't much left. There's the ultrasonic sensor and the touch sensors and the gyro sensor. But this is the one I think will get the most use out of in the tournaments. So this one is almost the same as color and looking for a black line. Right. So these two things are different. Is that this one might be looking for a black line, but it could probably find something a little bit lighter than black. Where this block will find a black line only. Definitely get started there with what you can. And they are two different things. This is great for when you can't read the colors for sure on a mat. Maybe your color sensor is too close to the field or too far away. So this one's really good for finding those. And this one is very specific onto what the color sensor does. So it only reads Lego colors. Black is obviously really easy, but reds, greens, blues, those things get a little bit weird if they're not Lego colors. I'm using the EV3 code. The NXT is older. It's a bit slower. It only has 3 motor ports instead of the 4 for the NXT. For someone who's never seen anything in terms of robotics, you probably won't even tell the difference. If you've never seen NXT or EV3, one is just the next technological advance. It's the difference between a phone that came out in 2006 versus one that came out in 2013. So a lot of them look the same, but the internals are going to be different. You're going to get a bigger change in the display, and especially the programming language for us. And I prefer the EV3 programming language, but some people still use the NXT. But for all intensive purposes, they do both of the same thing. They make robots go straight, and they make them do stuff with a third motor. And there's going to be more sensors available for the EV3, official sensors anyway, available for EV3 than there are NXT. And the programming language is different. And for someone who's never seen it, you probably couldn't tell. I couldn't tell you any difference between the two. We are actually stopping making updates for the NXT just because we have a newer platform out. So unfortunately, that's all we have. So if you have it, you probably have the latest updates. And probably the latest thing you could do now is use the EV3 software with the NXT. That's probably the latest thing you can do. The trouble with having a simulator is everyone's robot is different, And once you get there, then the robot doesn't do exactly what's in the simulator. My real suggestion for people is to build your robot and test it on a real field, because every field and environmental condition is going to be different for you in a robotics game. And no matter what you do in a simulation, your robot will be slightly different. And I really think it's important to have that real-world grip on it once you test your programs. If you really want to, just the best thing you can do for simulation is, take your EV3 brick and attach 4 motors to it and see if they run the way you want to. Right? And once you have that, I think that's going to be your second best virtual simulator. But I don't know of any off the top of my head directly that are direct simulators for us. But build your robot, guys, and I think you'll have a better. I think you'll get a better experience that way. I mean, I like having the real robot, but I would definitely get an add-on set for your box. I mean, it is up to use. I've seen teams do it with next to nothing, also using just one core set and one expansion set. So those kids got clever with what they've had. I think maybe some one EV3 set and a large Technic set might be fun to have. But again, you got to be really clever with what you have. Changing attachments like that will tell you exactly what you need. And every team's going to be different on how they use theirs. So as a coach, your best thing is to teach the kids how to go with limitations. You have to use what you can get, and the more you have, sometimes it's harder. Because for me, I have all the parts in the world, and I have trouble making robots for FLL myself. So I think it's a good idea to limit yourself when you can. Can you do it with just a core set? Can you do it with a core set and an expansion pack? Do you need a little bit more? That's going to be up to you as a coach to challenge yourself and the kids to see what they have. Yeah, we have quite a few here in the software. We have a quick start guide. We have a robot educator. So everything from basics like configuring blocks, straight moving, curved move, moving with the tank block, moving an object. So we actually have quite a lot of tutorials just inside the software itself. And but they're very basic, and they're not going to tell you how to do missions. So what you're going to have to learn to do is kind of take these and apply them to what you want to do. Our course set models and the expansion pack models are pre-programmed, so it's a good idea to go inside those and also take a look at the programs, see if any of those can do something that you need to do in your lessons or classes. So it's a good idea to study these programs. Like the puppy has a pretty cool program in it for adding behaviors, and it's a program in some modification can be used for First Lego League also. Color sorting is great. We had the search engine model in World Class, and maybe you could have used a program from there, from the color sorter. But there are tons and tons of web tutorials out there from people in the community. A lot of them are also from teams and from kids. But we give you a lot of cool stuff here. And it's using the base robot, which is slightly based on hundreds of FLL robots from the past. So I hope it's a good training for you guys to use this one. And you can see this one grabs an object, but that could be an FLL loop of some sort, and then you can see curve moving. So which curve is going to give you the best solution for your for where you need to go, which kind of turn. These are quite fun. So we got videos, and it should do what you want it to do. Let's see, they even have line following in here, I think. Maybe. We have it in here somewhere. Switch. There it goes. This one's line following. So we even show you that within our own tutorials. Let's see. Do I have? I'm gonna start my robot and see if I can do that. But actually, in this area of the, can you guys see this, Jen? But you have I have a robot here. I have an area here where you can see the robot itself and all the brick information from it. And I'm going to try and but you can actually erase the data from here. And then if you really want to erase everything, you can do a firmware update. And you can see all the brick information. I hope that's for EV3. But NXT is something similar. And, let's see if I can find the brick. But it's a good idea to try and find what you need to delete. So make sure you're deleting the right things. EV3 is quite good with memory, so I rarely actually need to get all the programs out, but it's connecting, and I hope it works. And you can see how to delete your files, and then you should be able to do it also from the brick itself. The second tab in the brick shows you all the file information. So. I just needed to. There we are. I hope you guys can see this, but you can see this button down here is Open Memory Browser. And then you can see all the projects in here and applications, and then I can go in here and delete this if I want to. So I can, okay, I can't delete that, but I can delete that block. And lots of space, lots and lots of space. So you've got lots of programs in here, big ones. So hope that helps. The search engine used the color sensor where you needed to see what color was in the mission to pick, right? So if, for example, the thing was red and you can have a color sensor read the red color, then you know which block to get without having to guess. You can have your robot do the actual picking for you. Last year we had a lot of different colored lines on the field. Sometimes the color sensor worked for those, trying to find red or stopping at green or blue. Definitely looking for the black lines has been good, especially for line following. And what else? We don't make it really need to be happening in world class, but what if you had to see the color of the loops? You know, those are good to see the colors of. Anything where you need to read a Lego color would be great to have that. So I see that happening a lot, and we hope to do more of those. Okay. Well, you can't calibrate the colors themselves, so, but you can calibrate the reading the light levels. So I'm just going to do this. So here in the yellow blocks, you can calibrate here. You can do the minimum or maximum. Calibrate. So maximum. So if I wanted to read this piece of paper, for example, and make sure that this was the brightest thing it could read, and I would run this program and actually show it this color sensor right now. And it would actually show, it would calibrate both color light sensors for the white. And then I could have it read the black part of my phone as the darkest part. And then you could see what happens. So let's see if I can do this. And then just to be able to read what's happening. I'm going to do it. So I'm going to make this color sensor read. And what I'll do is have a, and then calibrate. And now this is going to be the maximum. So that won't do anymore. See? Oh, actually still reading more, but this is the block to use for the calibration of the light sensor. And it helps a lot with the field, especially when there's different types of lights that you need to see. I hope this works. So that's pretty dark on the field right now. Try it again. There it is. There's my color sensor, reading 95 on the floor. So I wanted it to read at 100, but it's changing just a bit. And then you can do the same with the minimum value. And you'd want to do like one after the other. So you'd have to drive to a black zone, read the black, make sure it's 0. And I think I could do it this way too. Look at I don't know if you guys can see my sensor, but it's down here. Maybe it's too bright. I have it somewhere. It's a full calibration program. Whatever works for your robot is going to be best. I can't really make that great of a recommendation. Line following can be accurate in different ways. Sometimes pointing and shooting and measuring the angle can be working. What's easier for you? What's a better learning? What's a better learning for the students? If they learn how to measure the angle using the gyro sensor and get there every time, then that's great. If following the line, is another type of learning and programming, so that's going to be great for them too. I couldn't make a suggestion on that. I haven't seen any good videos seeing the gyro sensor in use exactly. Though I've seen a lot of teams do use it. I don't know if they made a video just directly of it. So using the gyro sensor can be a bit tricky, but first things first is resetting the gyro sensor. And something you could do with the gyro is get to an angle. For example, if I'm going to turn my robot at some point, I can have the gyro, I can have it stop at 90 degrees. At least what the robot is reading is 90 degrees. So this is one way to do that. So this is if the robot turns, sees the 90-degree mark, and then stops. So I have to warn you that this is going to be slightly different for every robot, and the reaction time of your robot is going to be different if you've got gearing and different types of wheels and slip. So, but this will be accurate as long as it's 90 degrees here. Your robot will turn to the same every time. So maybe you might need to read 80 degrees to make your robot turn perfectly. You might have to read 120 to make your robot read perfectly. That's quite cool. Another good one is the actual steering of the robot. And I've seen a lot of teams do this, is that they use the gyro sensor to always keep their robot driving straight. And you can always try to get it to drive to a different angle or something like that. So that's really quite cool in the robotics and using the gyro. So it's good to know. It's also great for data logging. So if you're reading that, you can read what your robot is doing, and then you can actually see a graph of what the gyro itself is doing. So that's pretty cool. And what your robot is doing, and you can make your robot change the behavior of your robot based on this. I don't know. I guess you can use two gyros. You can use, if you want to compare the two values, you can use. And there's so many limiting factors in there. So a lot of teams like to use direct drive from the motor to the wheel, and that's going to help with the slack on the robot, the gyro, the turning. So, keeping a constant reset on the gyro sometimes helps. But again, it's going to depend so much on your robot. And every robot's going to be different. 3 degrees might be perfect for what you need, and how much more precise do you need to be to 0? I recommend checking every couple of minutes or something like that if you're going the right way, for example. Well, it takes some clever programming to get there, and I hope you guys can find a way. Using it directly is one of the better ways to use it. Color sensor stuff, I've run into this problem too. Your practice field is going to be very different from the field from the competition. And you're going to need to be able to find out what's the best thing there, like talk to the organizers beforehand. Are they going to have lights? Is there going to be overhead lights, or is it going to be gym lights versus a room lights? I had to figure out that at a tournament one time I was finding the green color. and I was looking for the color. I was looking for the color green everywhere I could go, but then at the tournament, my robot wouldn't read it. It couldn't read the green, so I had to change my color sensor to a reflected light. Yeah, to reading less than 40, for example, or reading a range of lights where I knew exactly what the color was. And it's going to happen, but you'll have to be really clever with it. A lot of teams use a shroud around the color sensor. Like my color sensors here are kind of covered quite well, so that means no other light can affect that other than itself. Those are going to be really super important for you to try and get the right kind of reading on your robots. And yeah, it happens to the best of us, and it is a real world problem that your conditions will change. So you kind of just have to adjust for it and know ahead of time, when you can calibrate the robot at the tournament. So they usually give you time to do that, especially during a practice session. If it's a real stickler, at your coach's meeting, definitely, try to find out those light problems beforehand, before the tournament gets started. Share it with the rest of the teams. And you'll get a better experience that way.
If you've had a chance to read your coach's handbook, our First Lego League engineer and game designer Scott Evans actually has his 10 robot game tips on page 39 and 40 of that publication, which you can download from www.firstlegoleague.org. But one of his is regarding the optical color and light sensors, and he says a change in ambient surrounding light can mess up your optical color and light sensor programs. While it is possible to calibrate them, it is even better to avoid the need. Try to build your optical sensors into the center of the robot's shadow or make a light shield around them. And that's what Lee was just talking about just now. But I definitely recommend, if you haven't done so, to download the coach's handbook and read through it.
Well, you can give it a shot and see if it works for you. As long as I give credit to the people who made the original design, I think you're okay. Again, you're going to have to change your robot based on what you're trying to do. Again, especially for you as the coach, what lesson are you giving to your kids? It's are you trying to learn how to build a robot or just get points? So, what you want to do is really understand what you're trying to do with your kids, if that's okay with you to use a design from their robot. So I always like to say it's good to see what's out there and improve it. If you see a design you really like, see if you can do something better, because maybe that team wasn't perfect either. You just like the design. You can try it, but it's fun to see other people's designs. I always like to try and make my own, but maybe you're running out of time, or you're trying to make a lesson out of what the other teams are doing. So it's good to get inspiration and learnings from other people's designs, but give credit when you can give credit, and teach your kids something about building robots. As long as you get a good lesson out of it, then I think it's okay.
That inspiration piece is also why we always encourage teams, no matter how prepared you may feel or not feel, to make sure that you get to an event if you possibly can, because you'll just really be amazed at the number of designs you'll see and programs, in addition to the huge variety of projects related to the challenge theme.
The last tournaments I've gone to, I really love seeing other teams' robots and getting inspired by them, and bringing them into my work also. So don't feel too bad about seeing other people's designs, but they need to go into your own as well. Okay, break down your programs. I try to make them into smaller chunks to see what went wrong. Like I have a very big program here, for example. This is my sumo wrestling program. But for me, the only thing I really need to do is see this part of the program. This little part of it is the part I need to troubleshoot. So, break it down into smaller blocks that you can use. And also, really super important for you is to add comments to your robots, and to your programs rather, and find out exactly what's happening here. Break it down. Don't make these giant strings of programs because you're going to get lost in them. This one makes the robot forward to black line, rather orange line, something like that, I think. So, but in general case, yeah, try to stay away from making your program so big. Break it down if you need to. When you get to 100 blocks or something, it's learn how to stop your programs where they need to be, right? So if I know that these two blocks work all the time, and my robot gets to point C, right? This one goes to point A, this one goes to point B, and it stops there. And these two work all the time. I think it's good for you to just try to work on this part of the program and start the robot where this ended. And then you can place selection here. Yes, this works all the time, but this doesn't. So you can change it as you need to. If you really get into like doing my blocks and things like that, then you can make this a my block. No, that works all the time, so that you can kind of hide it from view. You can even zoom out of it. You can let yourself run the program so that you only see the part that you need to edit. All right, so make sure you know that smaller parts of the program work, and it's good to work in those kind of chunks. A great question on that one. A simple feedback controller is again a line follower. Instead of so this is a live reading color sensor as opposed to your passive ones down here. But if you have this, for example, right? You can use a little feedback loop here. So this is a simple feedback loop for a color sensor. And what this will do is as the robot gets closer to a reading of 40, it'll tend to go more straight. So if it goes to the black side, it'll turn one way. If it goes to the white side, it'll turn the other way. So you wanna see what actually happens there. And this won't bounce as much. So this is a really basic feedback loop on using that. Another one would be keeping things in a loop, for example, and using the gyro. The gyro also helps with steering. So that's going to help you keep your robot go straight, if you want it to go straight. I hope that's okay. There's some fun ones you could do too with different sensors. Yeah, you can do, there's a fun one. So you can do a ramp here. And what you can do is ramp up the power this way. And you can do it in steps. So this will do it to 5. So in not 100 seconds, but 100 counts. So let's just do 100. So this is a way to ramp up your motors. For whatever reason, didn't make it into our programming language this time, but this is a really easy way of making your robots go from 0 to 100, and this will take some time. And if you want it to go slower, you can change the amount of time that's in it. And I think I can show you this. So 3.1. This might take 10 seconds or something like that to ramp up. And then stops. And on the other end, you can do some, if you got some math, you can have it ramp down, which is pretty cool. So 100. And you have it run this way. You can have it go from 100 and slow down. Pretty cool. If I do this, selection. You can hear it if you can't see the audio, but this is a really cool way of doing that. So fun. Good question. So, okay, here's a good one. The timer block, I hope they're talking about this one. So, really important to reset it beforehand. But what I really like to do with the timer block is compare it with something else. So, what I want to do is, say if I'm moving, moving on, right? So if I'm moving and if I have a timer block, say I want to compare it to, so if it's greater, that's 5 seconds, right? And maybe some sort of sensor. So this is a really way. Jen, can you just tell me if you guys can see this?
Yes.
Yeah, you guys can see. And what a really great thing to do is compare the two blocks. Not down. Logic operations. So what I want to do is using the timer block, I can get this loop to stop if the timer went 5 seconds and the color is red. Or if the color is red. So if I'm doing line following, for example, I want to go for either 5 seconds or when I see the next color. Really important to be able to use a timer that way. but making sure that I reset this timer, because actually the timers start counting from the beginning of the program. So unless you reset them before they need to run, then this program will always be greater than 5. And if you reset the timer 1, it'll be 0 when this starts, and then you'll have your timer use. But if you're using if you're doing the line follower program, for example, right? Using the time here will make sure you stop after 5 seconds. So that's a little bit different than the actual timer block. I hope that helps. I like the timer block. It's very cool. Yes, batteries run out. So, you never know at your tournament if you need to change the battery very quickly. If you're using a chargeable battery, and yes, it's allowed to use one in the competition, I recommend it personally because they last a little bit longer. Even though they don't give the same kind of initial output, they give a more steady output in terms of voltage for a longer amount of time. And especially for FLL, they will last you throughout a day, but I do recommend keeping them charged. On the robot that I have in front of me, for example, I can't change the battery easily, but I can charge it easily. So back here, I made the charging cable easy to access because I know this is going to run out of battery really fast. I'm running 4 motors at the same time, and all of them at full power. So I want to be able to access my charge panel easier. And I can change the battery if I need to. But for your FLL robots, I highly recommend being able to change your bricks, your EV3 brick and your battery, making it easy to change those. So even if you have regular batteries, make it easy to change it. So good luck with your battery use. You will see a difference if when your batteries get low, very low. But for the most of these, you get pretty consistent. Let's see. A great attitude is probably the first tools. I mean, obviously having the Lego stuff with you is going to be great. Do some research on what's going to be part of the season, and try to be a step ahead of the teams. I try to keep some building guides around. There are some great books for building building ideas and things like that. So do some research on those. Your building instructions are great resources for building mechanics, and keep an eye on a couple of favorite YouTube videos of your favorite robots doing something cool. Have those kinds of inspirations ready for those kids, and I'd also pick up some team building activities from other sports, from football, soccer, baseball, whatever you can do to get your team going. Those help a lot, and those are great tools to have in your back pocket when things get hard. And just know that they'll need to practice to be great, and it takes a lot of hours, and the teams who spend the time will make great successes in terms of in their learnings and how they feel at the end of the day.